right. Give me a thumbs up if you have a full proof that you think works. Okay, about a third of us. Okay, I'm going to put another minute on the clock, minute and a half for you to finish up. But I don't hear much discussion, so I'm assuming that you've figured out a path of logic and you're working it through to its conclusion. If you already are finished, compare yours with people around you. If your teammates are not done, turn around and see if someone behind you or in front of you is done. So good morning, and with a proof like this, and with the proofs we did yesterday, we already know exactly what the last statement is and what its reason is. We always put the proof statement last. That's true for any proof. But we already know what the last statement, the last reason is going to be as well. The last reason is going to be because of the definition of congruent triangles. That was the whole point of the last lesson, was to prove two triangles congruent and then be able to say something about corresponding parts. That was the whole point. So I would like everyone to look at their second to last statement. Not your last statement, because I already know what your last statement is. What's your second to last statement, and what's the reason? Stephen?
The last statement is the triangle YOZ is congruent to triangle W1. And it's SAS.
Side angle side, okay. Sharik?
Triangle YOZ equals triangle WOZ by SAS.
Okay. Very good. So let's see if that worked out. Excuse me. So here's my proof. And I'm going to guess that many of your proofs are much longer, much more involved. And I'm going to show you that this was actually a very simple proof, but I tricked you into thinking it was something more difficult. And it all hinged on this. And I do this with you guys all the time, and I wonder sometimes if you guys catch on that you should be using this. Watch this. A little bit easier now, isn't it? Look at my evidence that I gathered. I used side angle side to prove the triangle's congruent. This side is congruent to itself reflexively. I already have this side is congruent to that side. So all I need to do is prove that these two angles are congruent to each other. How can I prove that? Right there. Definition of an angle bisector says that those are congruent. So now I have side angle side. Side angle side, And then once I prove the triangle is congruent, now I can say that segment YZ is congruent to segment WZ. So in actuality, it's actually a very simple proof. You got tricked or confused into thinking it was more complicated. Now, that was not the only way to do it. So Stephen, I am guessing that you first proved these two triangles were congruent, which got you that that was congruent to that. And then you knew that this was congruent to itself reflexively. And you somehow proved that congruent to that. Do you know what these two lines, intersecting lines, end up being? Can someone tell us what actually ends up happening right here? It's not indicated in the picture, but it's something that just happens. Kamoy? They do end up being perpendicular. Because once you prove that these two triangles are congruent, that means that this is congruent to this. And I'm not sure what theorem it is, I don't remember its name, but if you have two lines that intersect to form congruent angles, that proves that the two intersecting lines are perpendicular. We learned that when we studied perpendicular lines. I don't remember if that was theorem 8, 9, 10, or a different theorem, but I know the concept. And since those are 90-degree angles, well, those become 90-degree angles. And so he proved it by side angle side, but he had to first prove these two triangles congruent, then get this from that first proof, and then use it in the second part. Great approach. Wonderful logic he used. Sharik used the same approach. Anyone do it yet a different way? Well, hopefully you see the different paths of logic at this point. Does anyone have any comments or questions on today's warm-up? Now remember the purpose of a warm-up. My goal with warm-ups is to get your brain to the level of effort and thought that I expect for the rest of the block. And now I think I've achieved that. So, for the bulk of Chapter 4, we've been discussing triangles. And for most of that, we have been studying ways to prove triangles congruent. You have an entire toolbox now that you have at your disposal to prove two triangles congruent. Then we took, not a side trip, but we kind of went beyond that last time. And once we were able to prove triangles congruent, then we were able to prove other things from that. Now we're going to go back to triangles themselves. We're going to look specifically at isosceles and equilateral triangles, because they have some special properties that other triangles don't have. So, our objectives today are to prove some theorems about isosceles and equilateral triangles and to apply properties of isosceles and equilateral triangles. Some new vocabulary terms that you're going to see. The legs of an isosceles triangle are the two sides that are equal to each other. The vertex angle is the angle formed by the legs. The base is the side opposite the vertex angle, and the base angles are the two angles at the bottom. I don't expect that you got any of that, but that's okay because you're going to see it over and over again. So now, let's jump into the theorems. These have been on your cheat sheet. So, because of some properties of isosceles triangles, we get two theorems. And they're actually, one's just the converse of the other. The base angles theorem is going to be the focus. Everything else stems from the base angles theorem. If you have two sides of a triangle that are congruent, one, that means it's isosceles, and two, it means the angles opposite them are congruent. Now, I had a few students in another group that were struggling with the idea of angles that were opposite. So let me clarify what that means. this angle points to that side, this angle points to that side. This angle, the vertex angle, points to the base, down there. Okay? So that's how you tell what's opposite. So this angle is opposite this side. This angle is opposite this side. And if these two sides are congruent, then these two angles are congruent. And that is the base angles theorem. Any questions about that? Now the converse. You know that a converse means we take the hypothesis and conclusion and flip them around. So if the two angles are congruent, that means the sides opposite them are congruent. So we've got the base angles theorem and its converse. Any questions? Now, there are two corollaries that are all based on the base angles theorem. And they relate to equilateral triangles. If a triangle is equilateral, then it's equiangular. That's the corollary to the base angles theorem. And then the corollary to the converse is if a triangle is equiangular, then it's equilateral. Guess what? We can sum this up very simply. If a triangle is equilateral, everything's congruent. All the sides are congruent, all the angles are congruent. That's what these two statements are saying. Equilateral means equiangular, everything's congruent. So that's an equilateral triangle. Any questions about any of these? I will expect you to be able to say base angles theorem. You should be able to say converse. I'm not so worried about corollary and corollary, but you need to know the idea. Okay? Any questions so far? So let's go ahead and start using these ideas to solve some problems. Example 1, using isosceles triangles. Any diagrams that you see, make sure you just sketch them. Don't pick up the ruler and start drawing perfect pictures. That takes way too long. We want to sketch. So my usual process is I model something for you and then I ask you to do it yourself. I model something with you and then I ask you to do it yourself. I'm going to modify that a little bit. I've been doing this all year. We're going to make some of these examples interactive where I'm going to have you kind of do part and I'm going to do part and we're going to do parts together. So we have this intricate diagram. I got it from a resource and it said that it had something to do with astronomy. I'm not an expert at astronomy, and I honestly didn't know what it really was. So I didn't put that in here, but supposedly this has something to do with astronomy. Sorry, I don't know what it is. I hope I'm not shortchanging your education. But what we are told is that the length of this is 20. And I am telling you that this is also going to be the same. But I want you to explain to me why. Why is it the same? So I'm going to give you a minute, team talk, to come up with the reason or reasons of why it is the same. You got 1 minute to discuss with your team. Why is it going to be the same? to the equity bars. Team C. What'd you guys come up with? Sharik, what'd you come up with?
Since those two angles equal yxc and equals ydx, since both of them are congruent, which you can tell since the left one is going to be the right one, linear pair and supplementary angles, since those two are the same using the converse to the base angle theorem, the sides opposite to them are the same, and since one is complete, the other is complete.
Okay, so you gave us everything. I was hoping you were going to give me the beginning, but you ended up giving me everything. Because you said, oh, well, clearly this is congruent to that, but is it clear? And then you went off on an explanation. So I'm going to now tag team to somebody else. Let's see if someone else either caught what you said or figured it out themselves. Why are these two congruent? Alexandra?
Because the angle at 6 root 40 degrees, they become linear pairs.
Very good. I love how you put in that terminology, that this is a linear pair, and linear pairs are supplementary 180 degrees, which means that this is a 40-degree angle. And then using the converse to the base angles theorem, if these are congruent, then the opposite sides are congruent. So yes, YZ is going to be the same distance. Does anyone have any questions about that? So we still needed a path of logic. We still needed to think through. We still need to use our geometry ideas. We needed to use a little bit of basic math. Does anyone have any questions on what we did here? So let's keep developing the idea. So now let's get a little more formal and throw in some algebra as well. We're not going to worry about part B yet. Let's just worry about part A. I would like to find, with your help, the measure of angle F. So I would like that. What can we do? John, you've got an idea? Go ahead, what do you got? Okay, so subtract 22 from 180. And then divide the result by 2. Okay? Seems like it could work. Give me a thumbs up if what he said makes sense to you. Okay. Dayanara, let's make this a little more algebraic so we can see it in a more formal way. We know something about these two angles. What do we know about them, Dayanara? They're congruent because of the base angles theorem. They're congruent, and since they're both the same, we can give them the same name. What should we name them? Name them X. That was beautiful. So now, what would the equation be to put it all together? So, taking John's logical approach, but now make it algebra. Nathaniel? Exactly. 2x plus 22 equals 180 degrees. That was beautiful. All he did was say, this is a triangle. It must add up to 180. That's why John knew we had to subtract from 180. But all these angles have to add up to that. So now do exactly what John said. Subtract 22 from 180, which is what we do here. And then divide the result by 2, because we end up with 2x equals 188. So what is the measure of angle F? John, did you figure it out?
Yeah.
What was it?
79.
So x equals 79, and in this case, x is just the whole angle, so we get 79 degrees. Any questions on how we did that? So it's all based on the base angles theorem. Any questions, concerns? Good, we're doing well so far. Let's take it to the next level. So in part B, I would like to find the measure of angle G. We'll get to that in a second, but based on the markings on the triangle, could someone make a congruent statement for us? Just make a congruent statement about something. Come on. Very good. JH, segment JH is congruent to GH. Very good, and I love how she had the order of the letters correct. Could someone make another congruent statement based on something we're learning today? Alexandra? Beautiful. Angle G is congruent to angle J. Converting that from objects to measurements, we could say the measure of angle G equals the measure of angle J. And here are the measures. So can't we now substitute? Once we have it written in this form, we're allowed to use substitution. So the measure of angle G is x plus 44. The measure of angle J is 3x. Now it became algebraic. Solve for x. Go ahead and solve for x. What does x equal? You already got it? You guys are way ahead of me? Kayla, you already got it? Oh, what does x come out to? Well, x comes out to 22. Is it 22 degrees? Okay, so what's angle G?
No, I'm sorry. 66.
Good. So you caught your mistake. It's no big deal. Don't feel pressure. So what we did figure out was 22, but now you have to plug back into there. And so to answer the question, find the measure of angle G. The measure of angle G is 66 degrees. So in this case, in part A, the x happened to be the whole angle. In this case, x wasn't the whole angle. X was just a component of it, and we had to plug it back in. Any questions about that? Any questions about what we've done here? About the theorems that we're using? Okay, no questions? Checkpoint number 1. You've got 2 questions. You've got 3 minutes. Okay, stay on your toes. We got the equity bars coming back out. Part A. We're sticking with part A only. What did you get? I've got number 2, 20, and 17. Number 2, what'd you get?
66 degrees.
Okay, number 20, what'd you get? Okay, number 17, what'd you get? All three of you think it's 66 degrees. Measure of angle H is 66 degrees. Part B. What did you get for the measure of angle N? We've got number 14, 19, and number 4. Number 14, what'd you get? Number 19, what'd you get? Number 4, what'd you get? Measure of angle N, 48 degrees. Give me a thumbs up if you got both of them correct. Put your thumbs down. So clearly we got the idea. Let's build on it. Now let's explore the corollaries. So now, find the value of x. My instincts tell me that equilateral triangles should be super easy, like easier than anything else. But I'm looking at it and now I'm confused. Well, let's start out with what we could figure out. I kind of gave it away. This is an equilateral triangle. So what do the corollaries say about it? Stephen?
It's equally even.
I'm sorry?
It's equally even.
Yeah, it's equiangular. So all these are equal to each other. Okay, so that we know. And we know all the sides are equal to each other, but we're trying to find x, which is part of this angle measurement here. So I don't remember I don't know what to do. Nathaniel, you have an idea?
Yes.
What is it?
The angle addition. Yeah, all the angles together, which should be 2x plus 82, so we make 180 degrees.
Okay, so it's a triangle, so it adds up to 180. And so you're saying we would have to do 2x plus 32 plus 2x plus 32 plus 2x plus 32 equals 180?
And then solve.
Okay. Yeah, that makes sense to me. Okay. Anyone? There was a few other people who had an idea. Sharif?
Since it's an equal angle and triangle, are they all up to 180 degrees? Since they all have the same measure of angles and there's three angles, so we divide 180 by 3, that equals 60 degrees. So you set 2x plus 32 equals 60.
It's 60 degrees?
Yeah, each angle. Since it's equal angle and there's three angles, and since all the angles add up to 180 degrees.
Okay. All right, well, I was going to give you a minute of team talk to explore. We got a couple of ideas floating around. All right, so let's take a minute. So we have two proposals. We've got Nathaniel's proposal of 2x plus 3 plus 2x plus 3 plus 2x plus 3 equals 180. And you're saying 2x plus 3 equals 60?
Yes, it's all.
Because the angles are all 60? All right, well, this is what I want you to do then. You come up with either you agree with one of those methods or you come up with another method. Ready, go.
Well, no, you find the value of x.
Exactly. You just gave.
But that's
You gave the equation. You didn't give the answer.
You said 60 degrees.
That's not, we're finding the value of x.
Exactly.
That's 60 is not the value of x.
I'm not talking about the answer.
All right, so what did you and your team decide on or come up with? Well, I know what you decided on. Did you modify your thought? Oh, okay. Well, I know what you came up with. What did you come up with, Eric? Or what did you decide on? This is the point where words start coming out of your mouth. Okay, gather your thoughts and I'm going to come back to you. Sebastian, what did your team decide on?
What, x equals?
No, like what method to, like how to get it. Okay, so you guys did 2x plus 32 plus 2x plus 32 plus 2x plus 32 equals 108.
it's easier to do 3 times 2x is 32.
Okay, so we could change that to 3 times 2x plus 32 equals 180. And you felt that that was easier than Sharik's proposal, which I don't know if Sharik's proposal is correct, but he says 2x plus 32 equals 60. I don't know, out of all those, I would want to do the last one, but I don't know if his is correct. Did anyone actually check and see if his is right? Come on.
Because like, since the triangle equals like 180 altogether, and when you divide it by the three angles, you divide by 3, it comes out to 60, so you take that. And when you solve it, it comes out to the same answer.
Okay, so yes, of course, he's correct. And yes, I was just pretending to be oblivious, but of course. In fact, it was something that I was hoping that you guys would figure out on your own, is that all equilateral triangles will have 60-degree angles. Always. No matter what. If you make a small equilateral triangle, or you make a giant equilateral triangle, it doesn't matter. The angles will always be 60 degrees each because they're all equal to each other and they have to add up to 180, and of course it equals 60. So all three of these methods will work. But in my classroom, we tend to focus on efficiency. I also like to focus on creativity as well and thought. I love this idea of changing this into this. But this is by far the most efficient approach, and it's based on the idea that all of these are going to be 60 degrees. So let's get the answer. What does x come out to? What does it come out to? You figured it out, Stephen? What did it come out to?
14.
Comes out to 14. So x is 14, and you could check that by plugging it back into here. 2 times 14 is 28, plus 32 is 60, of course. So x equals 14, and Kamoy did the actual honorable work of checking all of them, and they all come out the same. So clearly we've proven it. Okay? Does anyone have any questions on what we just went through? All right, so let's see. What about here? Find the value of y. So, anyone have any proposals of what we could do? Be able to support it with a reason? What could we do? Could you?
It's like set the two equations equal to each other because like the corollary to the converse makes triangles
Okay, I love the explanation. This is equiangular, that's indicated, which means it's equilateral as well. So we can set this expression equal to this one. 5y minus 6 equals 4y plus 2. Plus 12. Solve the equation. It's actually a pretty simple equation to solve. Y equals what? Good year?
8.
Equals 8.
Oh.
I wrote, yeah, it's 18. So y equals 18. So using the corollary to the converse of the base angles theorem, we were able to say this, and then we were able to say that those were equal to each other. Any questions about what we did there? All right, checkpoint number 2. Let's see what you can do on your own. Find the value of JL. One question. You got 2 minutes. If you finish and there's still time left and your teammates are done, then you may start comparing your answers.
It's hilarious.
All right, stay on your toes. To the equity bars I go. And let's see what the value of JL is. We've got student number 9, 18, and 20. Student number 9, what'd you get? Okay, student number 18. Student number 20. You all think that it's 10. JL is 10. Give me a thumbs up if you got this correct. Clearly we're understanding. Anyone have any comments? All right, let's take it a step further. Find the perimeter of the triangle. Find the perimeter of the triangle. You got 2 minutes. I'll find out for you guys. All right. Well, since there was some time for discussion, I guess it was easier than I thought it was. Let's see how we actually did. Student number 2, 14, 16, and 4. Student number 2, what'd you get?
66 centimeters.
Number 14, what'd you get? Okay, number 16, what'd you get? Number 4, what'd you get? It comes out to 66 centimeters. Give me a thumbs up if you got that one right. Does anyone have any comments or questions or concerns? You can put your thumbs down. Any concerns or questions? Let's finish out the day with some higher level thought. Find the values of x and y from the diagram. You got 3 minutes.
What? That's easy. Just look at it. What? I need my glasses. There's a Y.
Did I overestimate the complexity of the question?
Yes. Good to hear. Wait. You all you have to do is look at it. Okay.
All right, take your time. All right, well, it seems as though I dramatically overestimated the complexity of the question. Everyone seems to already have the answer, and seems as though people had to do no work to get it. So what is x and what is y? Oh, but only a few people know? Kayla, what's x and what's y?
X is 3 and Y is 4.
X is 3 and y is 4. Which one did you find first? Which one did you find first, Alexandra? Why was that one so easy? But why is it 4? What made it 4?
It's a base.
You don't have to be formal, just tell.
It's an equilateral triangle.
It's an equilateral triangle, and so if that's 4, that's 4, which means that's 4, which means that's going to be 4, and so it really just kind of goes from there. Yes?
So like, it would be equal angular and saying that was like the kind is that kind of like an AAA sort of? Like you say equal
Angle, 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 I guess. Well, what would you say about... The problem is that equiangular doesn't mean that they're actually the same. Because you could do this. And it'll take me a second to actually do it, but... I'm just trying to make a copy of this triangle. So now we have an equilateral triangle, right? So it's equiangular. And he wants to know, well, could we use that to prove triangles are congruent? So now I have two of them, right? This is equiangular, this is equiangular, but now what? This is equiangular because look, no matter where I put it, the angles are the same. But clearly, they are not congruent triangles. So equiangular does not necessarily mean congruent. It just means equiangular, okay? I don't know if that was what you were saying, but it was an interesting idea that you had brought up. Any questions or comments? Good, draw a line across your paper. Your homework is on page 267. Going to do numbers 3 through 17, 20 through 25, 47, 48. You're doing the at-home tutor for lesson 4.9, and or you can read the pages. And you have a quiz on Friday, and that will be on 4.5 to 4.8. So it will go up to today's lesson.